This is varchar 2. Same. Whatever we had read with varchar data type are also same, are also true with varchar 2 also. But the only one small difference is if it is varchar, the size is 2000, and if it is varchar, the size is 4000. That's it. And everything was same. Both are same. 99% both are same, but size is 4000. That's it. And here also varchar. See, you don't have to specify varchar 2. Even if you make it varchar, automatically it will be considered as varchar 2. I'll repeat. Consider now I want to fill a name. I want to store a character. I'll go with I want to fill a varchar data type. Varchar. And the size is 20. And automatically the compiler will consider that this is not varchar, this is varchar 2. By default, it will automatically adjust itself that it is varchar 2. Nothing to worry about this one. And then the third data type we have done with character, done with varchar and varchar 2. Now we are up to date. So date, and that says it is used to store the date in a particular format. It is used to store the date in a particular format, and that particular format is Oracle format. I repeat, it is used to store the date in the database, especially with respect to the SQL. Date is used to store the date in a particular format, and that particular format is Oracle format. Oracle format, and the syntax is date. Syntax is date. So I'll ask the compiler, I want to fill a date. So just date, and request will be sent to the compiler, and response will be given back. That will be in the form of the particular format. The particular format is dd. So this is the particular format: dd mon yyyy or dd mon yy. So we know this one. Either we can write the entire year, or we can make it just the last two digits of the year, 24 or 2024. Both are same. So this is a Oracle format. You should remember this, the date format: dd mon hyphen yy or yy. So if I ask the compiler, it will give this one. So yy date, or today is 17 Feb 25. This is yy, the second one. This format. I have written the date in this format. You can write anything. So possible. This is date. Very simple. And then something called number. So number, it is used to store numeric values. Number is used to store numeric values, and we have the syntax for that. Number of precision comma scale. It is used to store numeric values, and the syntax is number of precision comma scale. We'll see what is precision. So precision says it is used to store the integer value. It is used to store the integer values, and the range of precision is 1 to 38. The basic. So I'll repeat. It is used to store the integer values, and the range of precision is 1 to 38. I'll tell you what is this 1 to 38. So this is precision. Precision is nothing but to store the integer value, and scale is nothing but it is used to store the decimal values. Or any idea what is decimal values? Decimal values.
Like point.
So decimal value is nothing but the values that comes after decimal. So this is decimal dot. After point, whatever the values we get, that is decimal values. And this is integer, for example. So this 2 is an integer value, and these are the decimal values. So similarly, here scale is used to store the decimal values, and the range of scale is 0 to 127. Range of scale, which means it comes with 0.1, 0.2, so on, so 0.9, and then next 1.0. Again, next 1.1, 1.2, so on, so 1.9, comma 2.0, and like this up to 127.0. So this is the last up to 127. up to 127 values that can be stored as a decimal value. We'll see one example. So it is used to store the decimal values, and the range of scale is 0 to 127, and the default value of scale is always 0. Scale value will always start with 0. See, this is scale value 0 0.1, 0 0.2. So this is a scale value. First, it always starts with 0. So the default value for scale is always 0. We'll see a few examples here. You have to pay attention very carefully. This is just an example. This is not that required, but still just an example how this data type will work. So I have a syntax: number of precision comma scale, number of precision comma scale. So the first will be precision and the next will be scale. And here we have the precision value 7 and scale value 3. Which one is highest?
Precision.
Yes. So I'll repeat. Whichever highest value we have from this precision and scale, based on that highest value, the compiler will produce a block. I'll repeat again. From precision and scale, whichever is higher, let it be scale or precision, whichever is highest, based on that highest value, the blocks will be formed. But filling those forms are up to precision value. I'll repeat once again. Listen carefully. We have precision value and we have scale value. Let it be whichever is higher. It might be precision value or scale value. Whichever is highest, based on that highest value, blocks will be produced. Based on the highest value, blocks will be produced. And whatever the blocks that are produced based on highest value, those blocks are filled based on precision value. For example, I'm having 7 comma 3. Which one is highest? Precision is highest. So precision value is 7. So the compiler will produce 7 blocks. 1, 2, 3, 6, 7. 7 blocks. So I have to fill all the 7. Whatever the precision value we have, based on that number, the number of blocks should be filled. But whatever the highest value we have, based on that, the blocks will be formed. We'll see a few examples. So I'm having 7 comma 3. Highest is precision, so 7 blocks are formed, and we have to fill all those 7 because I'm having precision value as 7. Or let it be some number 1 1 1 1. Let it be 1. So I have filled all the 7 blocks. What about this? What is this 3? Scale. What do you mean by scale? Scale?
Decimal.
Yes, decimal. But where I have to put decimal?
Decimal is like right to left.
Uh, is it right to left or left to right? Decimal. Decimal is always left to right. Left to right. Decimal values will always be left to right. So I'm having the scale value as 3. So 1, 2, 3. So here I have to put dot. Is it clear with this one? First one? And I'm having second one. So precision value 5 and scale value is 2. Precision value 5, scale value 2. Which one is highest? Precision is highest. And yes, I have to tell one more thing. So this scale is in square bracket. Scale is in square bracket. See, in SQL or PLSQL, whichever the things that are enclosed within a square bracket are optional. I'll repeat, whatever you find, whatever you find within a square bracket are optional. They are optional. If we want, we can use it. If we don't want, we can skip that. Is it clear? Yes. So the second example, 5 comma 2. Precision is 5. Precision is 5 and scale is 2. Which one is highest?
5.
Yes, 5 is
Precision value 5.
precision value, 5 is highest. So 5 blocks will be produced. 1, 2, 3, 4, 5. And all these blocks will be filled based on precision value itself. So let it be some 2. So 2. And I have the scale value as 2. Where can I place dot? Decimal.
After two
after
digits.
2. So 1, 2. So here it should be the dot. And I'm having 5. It is precision or scale.
Precision.
How come?
Because the scale value, default value is
So it is
0.
optional. So if it is
Optional.
just only 1, that is absolutely a precision value. So it is 5 and it is completely fine. And I have to fill all the 5 values, all the 5 blocks. 3. We don't have any decimal here because they have not given any scale value. And I'm having 6 here. Here also no scale value, directly 6. So 1, 2, 3, 4, 5, 6. And we have to fill all the 6. There is no decimal here. What about this one? Precision 3, scale 5. Which one is highest?
Scale.
Scale is highest. So 5. Still the compiler produces 5 blocks. 1, 2, 3, 4, 5. Now how many blocks should I fill?
3.
3 or 5?
3.
Sure.
Yeah.
Any other answer? How many blocks should I fill now? Is it 3 or 5? So it is, we have to fill these blocks based on scale, based on precision value. So precision value is 3. So we have to fill only 3. 1, 2, 3. And the remainings are 0, 0, 0. What about dot now? Decimal. Where I should put the decimal? Decimal.
Mm,
Scale value is 5. So from the last 5, 1, 2, 3, 4, 5, and here I have to place dot. So it is completely decimal value. It is completely scale value itself. And then this one, 2 comma 8. We have 2 as precision, 8 as a scale, and the highest is scale value, which has 8 blocks, and the compiler will produce 8 blocks. But let it be whatever the highest value it might be, but we have to fill those blocks based on precision value. Our precision value is 2, so we just have to fill 2 blocks. 1, 2, and the remaining 0. And the dot is here. And this one, 8 comma 2. Which one is highest? Precision is highest, and we have to fill all those 8 blocks. It will be number with 7, 7, and we have the scale value as 2. So from the last 1 to top. So this is how a number will work. This is not important. This is not much important, but still we'll discuss. That's it. Well, in future days, we will be storing some number values in the database. So you should know how this scale and how this precision will work. Is it clear with this so far, Abhishek and team?
Yes, sir.
Clear.
Great, very good. And then the last one, the last data type, large object. So from these large object, we have two, character large object and binary large object. So character large object, this one says it is used to store huge amount of characters, huge amount of characters. Oh yeah, character values, huge amount of character values up to the size of 4 GB. So it is used to store the huge amount of character values up to the size of 4 GB. For example, with respect to this one, I'm using varchar. I'll ask the compiler, I need to store 10,000 words. I need to store 10,000 words. Produce me the blocks. I'll send the request, but it says no, I cannot, because the limit is 4,000 here, just 4,000. More than that, it cannot produce even one extra block. In such case, what we have to do, we have to go with CLOB. So I'll ask the compiler, I want to store just CLOB. And if I send this request to the compiler, it will consider the request and it will give the huge number of blocks. It will give the pages together. You can fill whatever you want up to the size of 4 GB. So you would have seen any textbook, any diary. Like there are many like couple of books which are having lakhs together words, lakhs together. For example, if I'm writing any book, any biography book, I write on myself. So it has around 1,000 pages. It has around 1,000 pages, and each page contains hardly 500 words. Each page contains hardly 500 words. 10,000 into 500, hardly we cannot count it. So what I'll do, I'll store those words in CLOB. I'll save it here first so that all those text, whatever the biography I'm writing on myself, that book, it will be occupying the space from these CLOB. I can store the data up to the size of 4 GB. In case if you want to store the data more than 4 GB, this is more than enough actually. This is more than enough. It is enough. So from these 4 GB, we will go with just 500 MB. 500 MB can occupy lakhs together characters, not even lakhs, crores together characters. See, for example, if I go with this one, this is the file. I'm hardly having some hundreds of, not even hundreds, nearly 1,000 words I'm having here. And the size of this file is 48 KB. 48 KB, not even 1 MB, just 48 KB, the size of this file. Like this, we can store the characters up to the size of 4 GB. So that's how character large object works. CLOB. If you want to store the data more than 4,000, if the character value has more than 4,000, we have to go with CLOB. Then binary large object. Binary large object. It is used to store huge amount of binary values up to the size of 4 GB. Do you have any idea what is binary values? Binary of people from CS? And
Zeros and ones.
Zero.
Zeros and one.
yeah, binary values is nothing but which is in the form of zeros and ones. See, for example, we will think that this is some, we will think that it is like some stupid number, 0 1 0 1 0 1. But this is not a number. This is some value for the compiler. It might give some value. I don't know what value it will give. Let it be Nayak. I'll add one more, two more. So this is 0 0 0 1 0 1 0. But for the compiler, it is some value. It means it is some value. So binary value is nothing but the values which can be understandable only by the computer, not by the humans. But it is not required. But still, we can store. The people, the developers who are having some 5 years, 10 years experience, those people know how that binary language will work. So, but this is also one example. It is used to store huge amount of binary values up to the size of 4 GB. And to get that, we have a syntax BLOB. If it is character, CLOB. But if it is any number, that is binary language, I'll ask the compiler, I want to store binary values. So please send me the request. I'll send the request. It will give the response in terms of pages. It will give the pages up to the size of 4 GB. We can fill whatever we want, how much ever we want, and all those values will be saved in BLOB. So this is the data type. Is it clear so far with all?